This is Lab 5, magnetic braking with Faraday's law. The introduction and the purpose is to understand the interaction between the magnet and the aluminum foil tube. We're going to apply Faraday's law to that model, and then we're going to compare the real and model data that we do, comparing glow script and the actual model that we did. And procedures, basically we're just going to drop a bar mag down the tube, measure the time that it takes for the magnet to go through the tube, and model and compare in glow script. For fundamental equations, we have Faraday's law, Ohm's law, Biot-Savart law, and Newton's second law. Observations, we found these are the calculate initial values. We found that the average time that the magnet took to drop in real life was 1.67 seconds. Modeling observations, those are our initial values on the top. Bottom, we have our dipole, and we calculate that, and that's what we got from Lab 3. So this modeling illustration continues. So we get the delta flux over delta T. We find the gravitational force, current, and then we find the force of the loop, the magnetic force of the loop, and that we calculate the F net, and so for the model results, we get model time is 1.528 seconds, which is much faster than real time. So constant, and so what happens is it was a constant speed, which we can see in the graph, and that just means that the force of gravity is equal to the magnetic force. And the source of error is probably human. Foil error might not be wrap tight, it might be too much more wrapping than we thought it was. And as you can see, the red means clockwise and the blue means counterclockwise for the above demonstration. Explanation discussion, basically you can see there how the current works. And if you flip the magnet around, it would actually switch the current. In order to resist the acceleration of the magnet, it would just have to adapt to the new changes. So it would swap the current around to continue the resistance. And then what if the resistivity of the conductor were reduced as close as possible to 0? How would the dynamics of the falling magnet change? Since there's less resistance, there would be a greater current, which would cause the magnetic force and the time of the magnet to for it to fall to increase greatly. And then if holes and slots were cut into the tube, there'd be a lot more resistance, just because there's less complete rings, and then it would probably travel faster through the tube. Thank you.